All right, we're back. This unit's been all about inheritance. We've learned about abstract classes. More recently, we learned about interfaces, and we're going to get some practice with interfaces in via an FRQ. Now, interface, I wanted to do an abstract class FRQ with you to get some abstract class practice in. The thing is, College Board doesn't really do FRQs on abstract classes. And when I say that, I mean, I went back 10 years of FRQs and only saw interface related questions, not abstract class. Now, the idea is ultimately going to be, very similar as we saw in our discussions about abstract classes and interfaces. The differences basically aren't there, right? Java enforces this difference. But in other languages, such as C++, there basically isn't a difference between an abstract class and interface, only implementation. So that being said, here's an interface FRQ. This one you can see is from 2018. It says, the string checker interface describes classes that check if strings are valid, according to some criterion. So we see the string checker interface. It's got one method here, is valid. This is an abstract method, I know, because we're talking about an interface. It's also public, so don't forget, right here are modifiers. This is public abstract. Boolean is valid, right? And that's why we have the semicolon here, because it is abstract. We don't actually need a body. This is just giving you a signature so that other things can override it, and you can create string checkers. You can create an array of string checkers and put all types of string checkers in it, and then use your is valid. So a code word checker is a string checker. I love just straightforward. This sentence is great, right? Is a string checker. I told you all about is a relationship. So we're saying that this is beneath this. And I'll tell you what, we'll go ahead. I'm going to drag this over because I'm going to create a class diagram on the fly based on this, right? If I was doing this in person, right, keep in mind FRQs should be like handwritten in practice. So you would have the opportunity to kind of draw out a quick class diagram. We got string checker up top, and it has one operation, one function, one method, or whatever you want to call it, and that is valid. Now, is valid is going to take in, or sorry, it's going to return a Boolean, but let's add a parameter to it, and that parameter is a string. So here is our function, right? It is public. I need to show that it is abstract. Ta-da. Notice that our class diagram maker here italicized that. My class itself is also abstract, so I'll check that. And you see it is italicized. That's it. Right? Just looking at just this, you can't actually tell. Is it an abstract class? Is it an interface? Not until we come in with our code word checker. Code word checker. And we're going to say code word checker is a string checker. So I know we have a vertical relationship here where this is beneath this. Okay, because this is an interface here, we are going to use the implements. And just like that, I've created a class hierarchy. Code word checker is a string checker. This is an interface. I can tell because that is, italicized, but most importantly, this arrow shows implements. Okay, so we are going to have to do that, as we're going to see. A code word checker object can be constructed with 3 parameters, 2 integers and a string. The first 2 parameters specify the minimum and maximum code word lengths. So whenever we construct the object, we're going to provide a min and a max length that the word can be. The third parameter specifies a string that must not occur in the code word. In this example, it's a $sign. A code word checker object can also be constructed with a single parameter that specifies a string that must not occur in the code word. In this case, the minimum maximum lengths will default to a 6 or 20, respectively. So we're actually going to ultimately overload the constructor. We have this constructor which takes in 3 parameters. And we have this constructor, which only takes in 1. Now, when we pass in 1, the minimum value will default to 6, and the maximum will be 20. Okay, let's look at some examples. And you got to keep in mind, these are examples, right? You have to basically code this so that it's dynamic and can handle these examples. We'll end up creating a driver and testing ourselves. But your code needs to be able to come up with a constructor that takes in 2 integers, a string, and then, initializes these things correctly. So looking at this example, right, they create a string checker object, SC1, right? We can save Codeword Checker, this object data type, into this variable because Codeword Checker is a string checker. It is equal to or beneath string checker in the class hierarchy. Now, whenever we construct this one, we're saying that the minimum length of our string is 5, the maximum length is 8, and it cannot contain a $sign. Otherwise, it would be, right, if we violate any of these things, it is not valid. Keep in mind, we ultimately have to override this method, right? It's an abstract method. We're extending it. Codeword Checker is either going to have to be abstract or it's going to have to implement the isValid method. So this is kind of the upfront criteria. If we look at some examples, they take the object that gets created up here, SC1, and they test happy to see, is happy valid? Well, it meets the minimum length of 5. It is shorter than the maximum length of 8, and it doesn't have a $sign. So true, this is a valid word. Okay, happy $sign contains a $sign, so false. It is not valid. Code is too short, right? We have to have a minimum length of 5, and happy code is too long because it goes over the 8. So that's what's happening here. In our second example, they call a different constructor where they pass in pass, and that is the word that cannot appear in our string. So when we do this no args constructor, this single args constructor, the one that takes in a string, our minimum length is going to be 6, our maximum is going to be 20. Okay, so then we test my pass, and we want to know, is that valid? Yes. Why? Well, it has pass, but you got to keep in mind, this is case sensitive. Okay, so that one is ultimately valid. It meets our minimum length of 6, and it is no longer than 20. My passport ultimately contains pass. Happy is too short because it is under that 6. And whatever this is too long because it is over the 20. We're going to test all of these things, but first we need to write the class. Right here it says write the complete Codeword Checker class. Your implementation must meet all of the specifications to conform to all examples. So looking at this, I know I'm going to need 3 instance variables. One that represents my minimum length, one that's my maximum, and then one that contains this little string here. Did they give me like a word to describe that? Just the string that does not occur. How about str? That's going to be a sweet variable name. So I need instance variables to save these things into. I'm going to need 2 constructors that initialize those instance variables. And the last thing I'm going to have to do is override the isValid method. And I know this because Codeword Checker is a string checker, meaning it implements our string checker. Okay, I'm going to hop over to IntelliJ. Right, in practice, we would handwrite this, but I can quickly mark it up in IntelliJ and also test it, so I don't feel too bad. I'm going to create a new project. We're going to go next, and sure, we'll do. I'm going to create maybe a folder here, FRQ 2018.4. Sorry, 3. This is number 3. I'll expand my project folder, right-click on the SRC. Let's make a new class. Now, you would not have to make the interface, but because I'm coding this from nothing and I want to have something that works to be able to actually test this, I'm going to write this interface super fast. I'm going to select interface from my IntelliJ dropdown. That changes a whopping 1 word for us. right? The name of this interface is called string checker. Okay, the only word that checking, by selecting interface, the only thing that we change is this from interface to class, right? That neat. It doesn't really save us much. So don't think that you have to select interface. If you selected class, just change the word here, change it to interface. You actually notice that as I change this, right? If I switch this back to class, IntelliJ has no problem, right? It changes the little icon here from a C, but this is ultimately still a .java file. The word interface, it's really not that different from an abstract class. So don't make too big of a deal out of it. But we're going to bring in this is valid method, right? Boolean is valid. We take in a string, which I believe they called str. Brilliant name. Love it. Don't forget that this thing is going to assume public abstract. I can explicitly type those in. IntelliJ is going to gray these out for me, indicating that it is useless. It is redundant. You don't need this because it assumes public and abstract by default, right? An interface is just the abstract stuff of a class. No instance variables, because we don't have instance variables, we don't need constructors, and there are no concrete methods. Only abstract methods. That's what an interface is. Okay, I'll go ahead and write this comment. Returns true if str is valid. Sweet, thanks. Return true if str is valid. I'm going to right click on my SRC. Let's get to the meat of this, which is creating a concrete class called Codeword Checker. This is where we would start, right? This is where you would actually need to start handwriting because they just give you a blank page and say, go for it. That means you would need to include the header, the class header, the braces that indicate the body. We're going to need to come in with some instance variables. I need 3 in total. 2 integers, one to represent my minimum length, one the maximum, and str, right? Whatever this little string that cannot appear in our string. So I'm going to create those instance variables. Now they need to be private. The College Board will take off points if your instance variables are not private. In fact, it may actually even say it. Oh, it doesn't say it here. Make them private. So we're going to do private int min, and I need a second integer max. I'll go ahead and declare this on the same line. You don't have to, right? We could say private int max. Do separate lines if you would like. And then I'm going to need a string, which is the thing that can't appear in my thing. It is the string that cannot appear and the string that I'll ultimately test to see if it is valid. Now, I aim to call it str, but I am going to have to override this method at some point. And I would also kind of like to use str there. That's not going to be a problem, right? So there are my 3 instance variables. We need 2 constructors. Public Codeword Checker. I need to take in a min, I need to take in a max, and I need to take in a string to store into str. Now here I'm using matching names, right? These have the same name as my instance variables. You know that you can have local variables with the same name as your instance variables, but you're going to have to differentiate between them. That is, this .min is equal to min, right? I'm saving the local variable, the parameter that's coming in, into my instance variable. I'm going to do that for all of these things. Ta-da! So all our constructor is doing is initializing these instance variables, saving in these 3 values. They end up getting used later, right? Because ultimately I need to override the isValid method. I say I need to because don't forget Codeword Checker is a string checker. right? I need to establish this class hierarchy. This line shows implements. Because string checker is an interface, we're not extending, we're going to implement string checker. Okay, and then we see the I need to part of this. Either Codeword Checker, this class, becomes abstract. You don't want to do that. This is a concrete class. I'll show you how I can tell it's a concrete class. They give examples where they actually construct it, right? If Codeword Checker was abstract, I couldn't do this. If Codeword Checker were an interface, I couldn't do this. That's how you can tell, ultimately, right? There's a little bit of, well, logically, blah, blah, blah. No, just looking at this syntactically, I can tell that this is a concrete class because you cannot create instances of an abstract class or an interface. So this has to be a concrete class. So this option of turning Codeword Checker into an abstract class in order to fix this error, that's not a thing. We have one option, and that is the other option. Override all of the abstract methods coming in from string checker. Well, there's only one. It's valid. I need to override that. In order to correctly override, I'm going to have to say public boolean is valid, taking in a string, which I will call str. Okay, notice the header is no longer mad at me. We are successfully overriding. Overriding occurs whenever the method that we are inheriting, right? Keep in mind that even though this is implements, this is kind of like extending. We are basically extending string checker, which means we would be inheriting this abstract method. In order for us to override it, we got to match the signature. I am doing so here. Although this one's not abstract because I plan on actually giving it a body and implementation. So our Codeword Checker is valid. This method needs to actually check str coming in to see if it is valid. Now, a reminder, in order for a string to be valid, it has to be within this length. Notice that it can be the minimum value, and I will assume it can also be the maximum value, even though we don't see an example of that. I'm assuming this is 5 and 8 inclusive. Did it say? I'm just going to assume correctly. It also cannot contain str. Okay. This can just all be done actually at the point of return. If str.length is greater than or equal to my min, row. I've been working with arrays in computer science principles. Length is a method, so we got to make sure we call that. If our string's length is greater than our minimum, and our string's length is less than or equal to our maximum, and our string does not contain, I would consider breaking these up, and str does not contain this.str. Okay, what? So this is what I was talking about, why I would consider calling this something other than str, is because down here I have two strs yet again, the local parameter, as well as the instance variable, and I have to differentiate between the two. So what I'm saying here, right, we're going to pass in a string here, right? Examples that they gave us was calling something like is valid happy. So happy is coming in as a string, and I want to know, is the length of it greater than or equal to my minimum accepted? Is the string length less than or equal to my maximum accepted? And does happy not contain this.str? Now, if I had to do str, bruh, you see, IntelliJ is like, that ain't going to work. This is the local variable, seeing if it is in itself. Does my local variable, does str contain str? Yeah, always. Right. So because I have two strs, I need to differentiate between the local variable and the instance variable as such, right? This would be something like a $sign in our example. I want to say, does happy not contain a $sign? That's it for the is valid, right? We do this all at the point of return, and I chain it together with some and logical operators. Easy, man. Okay, I'm ready technically to test this. I can test this constructor. We do still have another constructor that we need to write in, but why don't I go ahead and test my first little bits here. I'm going to create a driver. We'll plug in a main method, and we're going to create a string checker here. I'm going to create string checker SC1, and that is a new code word checker, and they gave us 58 $sign as an example. Now, I want you to notice that I wrote my code so that it handles anything, but I'm testing their examples to see, are we getting the right stuff? Notice also, IntelliJ is not mad at me. You can do this. Codeword Checker is an instance of string checker. Codeword Checker is equal to or beneath string checker in the class hierarchy, right? It is equal to or beneath in the class hierarchy, so we can save this in. I know this thing is not abstract because I can actually construct an instance of it. What do I mean? Well, if I try to create a string, right? If I said string checker SC2 is a new string checker, I've got to be careful not to hit enter. This is going to be very mad at me. And I scroll over it. It is abstract. It cannot be instantiated. You cannot make an instance. You cannot create an object, right? This logically makes some sense for us because there isn't even a constructor. Now, that doesn't really hold true with the whole abstract class thing, right? But this was just an aspect of an abstract class / interface, is that we cannot construct an instance of it. The reason being is because I have methods here that are abstract, right? If I could do this, if I could actually make an instance of it, well, and then you can see what SC2 is capable of calling. It can call is valid. Well, that just breaks the whole thing. The reason being, this method is valid. It doesn't have a body, right? I would be calling string checkers version of is valid, and it doesn't have a body. It is abstract. So that just breaks. That is the whole reason why you cannot create an instance of an abstract class or an interface. But this Codeword Checker is a concrete class, so we can make an instance of it, which I do here. Now we're going to take SC1, and the compile time data type of this is string checker. That means I'm limited to calling string checker methods. It's just these. Is valid is really the only one that we're writing. The other ones are technically coming from object. Okay, so is valid. I want to test some of their cases here. Happy. This is going to give me back a true or false value. So for me to actually see it in our program, I'm going to print that off. So I'm going to do an S out on SC1. That's our string checker up here. Is valid on happy. We'll do this one real fast, and I'll plug in the rest. True. Is that what they got? True. Let's do this one. Come on, copy and paste one time. Bruh. I'm going to do an S out on SC1. Is valid. Happy $sign. S out on SC1 is valid. This one is what? Code. And the last one was happy code. All right, they ultimately got true, false, false, false. We should get the exact same thing here in our output. So I'm going to tell this thing to run. And there we have it. Okay, this one met the minimum requirements, and it does not contain the $sign. This one contains a $sign, which is why we're getting a false value there. This one's too short and doesn't meet the minimum requirement. This one is ultimately too long. It goes over the maximum. So all we have left to do is overload the constructor. Okay. We need to be able to take in str and then set our min and max to these defaults of 6 and 20. I'm going to hop over to my Codeword Checker, and we will overload the constructor. We will take in a string. Okay. Now, to keep the order the same as what I see above, I'm going to go ahead and initialize my minimum value. It is going to be the default value of 6. Quotes. Our maximum is going to be 20, and I can use the parameter coming in to set the instance variable. It's the same as valid method. We are just overloading the constructor. And what that's going to allow me to do is in my driver, create a string checker called sc2, and it's a new code word checker. Okay, here are some of the test cases. My pass, right? So sout sc2 dot is valid on my pass. sc2 is valid on, oh, capital my doesn't really matter. My passport happy. And the last one was a big number in quotes. Oh, how many zeros is that? 15? Okay. All right, let's try this. So I'm looking at the next batch of 4. Right, these printouts here. Ultimately, they got true, false, false, false. Right? This one is valid even though our word is pass because it is case sensitive. The contains method is naturally case sensitive, so we don't have to worry about it. This one does contain pass. It is sneaky. It is right there. So that makes it invalid. Happy is too short because our default is 6. And then this one is ultimately too long. It goes over the default value of 20. Right? We did our min and max at 20. Okay. The last thing I'm going to show you, this is kind of what I would expect from most students. I feel like most people could just do the is valid at the point of return. Most people would probably tackle the constructor as such, but I did want to show you a different way that you can handle this constructor because I've got 2 constructors. I'm overloading it. I could chain them together. That's a me term, right? I'm coming up with this. But we can have this constructor just simply call this one and have it do all of the work. Super unnecessary, but I just want to show you different ways of solving these things. I'm going to say this, parentheses. We're going to search for a constructor in this class, specifically one that takes in 2 integers and a string. I'm going to pass in the min value, the max value, and str. This approach is nice. Our constructors, there's not a lot going on. But imagine this constructor did have a lot going on. And really, you just wanted to give client classes, users, people that are using your class, more options by overloading the constructor. Well, if this one is doing all of the work, I don't really want to copy and paste and create duplicate code for something that really isn't that different. So instead, what I'm doing is chaining this constructor to this one. So now what happens whenever we call Codeword Checker that takes in just a string, our flow comes here, passing in the string, and it calls a constructor in this class that takes in an integer, and a string. There is one constructor that matches that signature. It's right here. So we got 6 coming in, we got 20 coming in, and str comes in. This one actually initializes it, relinquishes control here, which would send back control here, and it should continue as normal, right? So ultimately, we're going to get the exact same thing, but that was a different approach. Again, here, it's not saving us much, but if our constructor was pretty complicated, this would be a better approach. Not only does it reduce duplicate code, but changes that I would make to this constructor, right? Any changes I make to this constructor affect this constructor as well. And so that would help us long term. Okay. So ultimately, this would be our kind of our solution to the FRQ. And it's a good place for us to stop. I'll see you in the next one.